Hello everybody, welcome to the second talk. My name is Stefan Birkner. I'm talking about this lengthy topic, mock and stub servers are good enough. I will explain in a minute what this is all about. So who am I? I'm like Abdullah, I'm a software developer at Source Labs. I'm only here for half a year, but already. I'm working with DevOps, continuous integration, delivery, deployment, etc. for I think more than 10 years. Apart from my daily job, what I'm doing, I'm JUnit committer, so more on the JUnit 4 side, not so much on the JUnit 5 and JUnit Lambda side. I have this library system rules that is a little bit popular for the specific topics that it handles. So whenever you are doing something in Java and have to test something on the system class, like properties, environment variables, etc., that will help you. And on Twitter, you can find me with my name without an underscore. You will get somebody different with an underscore, then it's more about politics. So, what I'm talking about today, I'm talking about a few things about toolbox. So when it comes to testing, we have a lot of tools, a lot of different kinds of tests. And I will talk about something specific about integration tests, and I will more talk about not integration tests. So, because this is something that people, when I talk to people at meetups like this, or maybe somebody's also visiting the software craftsmanship with the Dean Coffees, there is very often the topic about testing applications in a, let's call it microservice world. And a lot of people say, okay, we have a lot of integration tests, and the integration tests are a pain. And if you talk more and more, you find out that everybody thinks integration tests are always necessary. So, obviously, I think that's not the case. But of course, you saw Abdullah's presentation, and there you saw there are cases when it is necessary, and there are cases when it is not. The cases I'm talking about are stateless applications. So whatever I talk about today is about stateless applications. We have an application, the one in the middle, that is the one that we build. Usually have a client that talks to the application, and the application talks to other services, and sometimes has one or two databases, or sometimes more. Also today I'm only talking about classical HTTP, but it doesn't matter which protocol you use between the applications. But most people are used to HTTP, so I keep with that. So let's just go back. Who is building applications like this? Not so much who's building applications at all. Okay? So from the people who are building applications, a lot build applications like this. Who's doing integration tests in order to ensure that they work? Who likes the work that he has to do with integration tests? For whom is it really easy? Okay, we have one.
It depends on what you're integrating.
Yeah. So, and also when I'm talking about integration tests, because this term, people have different opinions what an integration test is. For me, it is, in order to test the application, you also have to start an instance of some service, and sometimes even an instance of the service if some service use. So, what's the main problem? Integration testing is costly. You have to, sometimes, not always, I will come to that also at the end. It is costly, you have to set up, you have to know things about the other service. I think a common scenario is You get a new version from the service, but you didn't set one environment variable, nothing starts up, you have to find out this one environment variable. So not the first time that you encounter this. I think you will meet a lot of developers who run into that problem. So what does a stateless application do? So as long as no request comes in, the application is idle. It can do whatever it wants, but it doesn't matter. The interesting thing is when we send a request to the application, something happens. For example, here, let's say our application is a kind of a kitchen. So somebody orders 100 gram of tzatziki. What happens in the application? So the application maybe has an own store, looks up what it is there, cucumbers are already there, then it finds out what it still needs, sends a request to another service, a store, that it wants to have a few other things. It gets a response back from the store, the things that it just ordered. And then it, with all the ingredients, it makes some tzatziki and gives it back to the client, to the user. And also it updates the local store. So from the outside, that is always what happens. Inside, there could be a lot of logic and whatever. But finally, these are the frame within my application works. Oops. And I only showed you the request, and finally what you can do is that you can run a test. So set up the GP, set up the external service, start your service, then the action, you send a request to your service, and then you get a response back, so you check that the response is okay, and you check that the database is in the state that you expect it to be. It's all example-based testing, so you have some examples. If the test plays the example well, everything is fine. So, sounds easy? It is easy. So, you will get a lot of tests like that, but you add it and everything is green, you can deploy your application. Some will think about testing pyramid, etc. I will come to that later. But let's say you have this frame for more or less every use case. You define the interaction with all the external services, and if that is still the same, your application is deployable. So let's look into this a little bit deeper, because it sounds easy, but we have to understand why it is like that. So, what your stateless application finally is a function. Because based on the request you send in, and the database state that is the current state of the database, and all the defined communication between the other service, whenever this stays the same, you get the same response. So this is nice because we know whenever something is functional, it has some properties that we can use for testing. Normally, what do we do with functions? You can just make some called the data-driven tests, JUnit and TestNG call it parameterized, whatever. So we could just define different sets of these, let's call it objects or whatever. And if our test runs successful, this is different sets. One was the one that I presented to you just a minute ago. Then the application does still the same like it did before. So let's think about what we are doing with the application. It's okay, we write the test, the application does the same like before, we could test that. But this is only important if we do what we are hired for if we change the application. Because an existing application, we don't need developers for it. So changing application, I think there are 3 cases what we change in an application. Still, I'm talking about this kind of status application, this request response, maybe a queue, whatever. So one thing is the refactorings. We just internally change something in the application to make it more maintainable. And the other thing is we add new behavior, just a new feature, shiny new, no interaction with the existing features. And last thing is we change existing behavior. So when speaking about HTTP applications, we change the behavior of an endpoint. So here's what our application looks like. And I would to place these 3 different scenarios with this application. So first is a refactoring. That's kind of easy. We only change code within our application, but outside it stays the same. So for refactorings, as long as we refactor and the test that we already have, this whole test suite is still green, everything is fine. Because from the outside, the service looks the same. Yeah, that's the easy case. Now comes the next case is we are adding a new endpoint, which means there will be a new request to the application. We talk in a different way to the other service, and maybe we store different data in the database. So in that case, we have to think that our development process has 2 steps. Because first, we have to find out what our application has to do. So, for example, we somehow have to find out how we work together with some service. We have an assumption how it works, but finally we have to test it. This may mean that we have to start the service locally, that we do that in some development environment, whatever. But even in production sometimes. But this is a phase where we still find out how it is. We prove our assumptions about how some service works. And that is very similar to what we are doing in integration tests. Only that we don't do it once we know how it works. So once, when we did this for a longer time, we finally know how the service works. And then we know which requests we send to the service, we know which responses come back. Now, based on this, we could build another test like we did before. And we don't need to do integration testing anymore, because we found out how our application interacts with some service and all the other stuff. And now, as long as it always does the same, it doesn't change, the application is green. We can deploy it. For that, the important thing is 2 phases. First, find out how it works. Use the existing application or whatever you can. But once you know that it is okay, then you could just freeze that. You could define which responses you send to some service, which requests are you getting back. And these tests you can then use for your regression tests that are part of your CI or CD pipeline. And after that, there's the 3rd case where we change behavior of existing endpoints. So why should we do this? First, don't do it. Some people think, oh, I always have to do it. Don't do it. In most cases, if you have to change an endpoint, it's much easier to add a new endpoint with the same functionality, but with these things that you just want to fix. Everybody could decide to use a new endpoint or the old endpoint. You don't change any behavior. But sometimes that doesn't work. For example, you have an endpoint and there's a bug that causes data corruption. You don't want to have that out for longer. So in that case, you modify existing code. Finally, it is very similar to the case before when you add an endpoint. So you have to change something in the application. The communication with your downstream services will change. You find out how it works, and finally, when you found it out, you freeze it, and based on that, you write or modify your test. The nice thing is that you also see if some other of your test changes, because this is a risk here. So you change something existing, you know for sure it is only about this endpoint, and then finally you find out, oh, my test here at this endpoint changes, and this test changes too. Then you have two chances. Sometimes it's okay, but you have to invest by yourself. You look at it, and you have to find out, is this okay that it changes? Or is this really a bug? If it is a bug, of course, you fix it and you have a new route. If it is not a bug, you just change the test. The nice thing now is, in your repository, you have a commit, and you see also how it affects other things. So the commit says, I fixed return type A to B, and then you see the test, and also affected is something here and something there. For you at that moment, it is not so important, but for somebody looking at the code 3 months later, it's very helpful to see that you also changed something that was not originally expected to be changed. So, finally, what it is about. I thought I want to get rid of, I don't use integration tests when I don't have to. But it is not so that integration test doesn't give me any value. So yes, a good written integration test gives you more confidence about your application than only testing one application. The thing that you have to decide is simply, are you playing a little bit with your chances and say, okay, I don't have to catch every corner of the application, so I may see the problem if it is in production and it is only corner cases for maybe 2 of a million users. Or you say, I really want to avoid it, or at least get the probability, the likelihood down, and then you have to invest money. In that case, mostly it's time. And yeah, you can select whatever you want. You can be on the right, at the left side, in the middle. But finally, you have to find out. The problem is also with integration testing. If you are in a microservice world, finally you will find out that you have to set a boundary. You cannot test everything. That sounds, for some people, a little bit strange, but we are already used to it. I give you an example. Who of you built a web application with a map on it? It's a Facebook login. Who GitHub login, or OAuth login. I think nobody of you started locally a Google Maps server or a Facebook server. So we already don't start everything that we use. We only start the things that are built by our company. But the others, we already only test against the interface. For example, for Google Maps, for sure, in this discovery phase, you find out how to interact with that map. But then finally, you may only test that you send the right data to it. And because, of course, you cannot easily start a Google Maps server on your own. And you have to be prepared that this part may change. But this also is another part when you build applications like this. This is why I said, if you don't have to, don't change your API. Because also Google or OpenStreetMap will not change their API for some little thing. Because you will finally break customers, because they rely on your API interface. And you want to have at least changes as possible, especially if you are more than a team of 4 or 5 where everybody knows what is happening out there. The other thing, the pyramids. The famous testing pyramid. So I said, okay, you always test on this black box level, but it doesn't influence whether you do integration tests or not. You can still decide to have inside the application a testing pyramid. The only thing that you have to ensure is that you really test every case from the outside, from a black box view. So everything that is possible and that you care about should be completely tested. And if you do that with a testing pyramid, that's fine. So one thing colleague of me said about the testing pyramid, because we had always these tests on this black box level. So he just said, so yeah, write a unit test for TDD. Once it works, throw it away. They fulfilled the need. No need to have it anymore. But this depends a lot about your starting time of your application. So yeah, I have to do that. With Spring Boot, it's a pain, but applications can start a lot faster. And then you can do these black box tests in seconds. But you have to ensure that your application starts in milliseconds and not in seconds or minutes. So it can be done, but you're free to have a testing pyramid inside. If you guarantee that you test all the communication, all the cases, that's fine. You still don't need the integration test in your pipeline. So important thing in our pipelines. So you need to test some integration once you're discovering the services that you use, because you have to find out how it works. That can be on development side, that can be in production, behind tokens, etc. But in the CI/CD pipeline, you can get rid of it. In the case of a stateless application, of course. So if you take something with it, think about it, and you may find use cases where you can do it, and it will make your life easier. And I hope that I can talk to a lot of you about whether this is possible or not. So it is possible. I did it in other companies too. It worked pretty well. Talk to me. And thanks for listening. About the questions. This time I get a pro tip. You tell me your question and I repeat it. We can get rid of that.
I thought you guys might pick up. So you just said it's okay to test in production, if I heard you right.
Yes.
Okay.
Okay.
You spent about a millisecond on that, but I would like you to take some more time and tell me why it's okay to test in production.
Okay. Yeah. The question is why it is okay to test in production. So I think it sounds crazy because everybody thinks something different about production. I'm not saying that you build the whole feature and finally test it in production before you're testing it locally. But if you want to discover the requests, for example, you can deploy hidden things in production and find out how it works there. Sometimes that's important, sometimes it's necessary, especially if you have a variety of data that you never have in your local setup, etc. And you really have to find out it because you don't know. If you have a really good knowledge about the services you use, you may do it in dev or in a staging environment. But sometimes you really don't know a lot about the living environment, about the data there, and you have to go there.
That sounds suspiciously like monitoring and not testing. Am I wrong?
Yeah, to be honest, for me there's no clear cut between monitoring and testing. Because what is testing more than monitoring a few use cases that you just create by your own?
I think it's who responds to it is the most important thing.
Okay, the answer was it's about who responds to it.
And when, where, with how much urgency?
Okay, yeah, and the urgency, of course. I think that depends on your setup. So who cares about production? Of course, if you have a thing where somebody else, ops, runs something in production, it's obvious that monitoring testing is something very different. If the same developers that build the application also run it and watch the monitoring, then it gets much closer.
Continue this question. So why do you need to run in production? How about copy production, anonymize it, and then run it?
Have you ever copied terabytes just for spinning up a local machine? So it depends on the amount of data, and it depends on the data itself, whether you are allowed to copy it. Any other question?
I just have to ask because last time we had a talk about consumer-driven contract testing, and I would like to hear your opinion on whether they are in addition to integration tests or whether they are like the same, and how you feel that both of them fit together.
Okay, the question was what is my opinion about consumer-driven contract tests and also in regard to integration testing, etc. So the important thing, let's say, about the consumer-driven contract testing is the consumer part. So otherwise, it is more or less the same what I talked about here. So the consumer specifies kind of your test, gives you an example that you test on your machine. First, when I compare it to integration tests, I think the bigger difference is most times that you run your consumer-driven contract tests only against your application, where every downstream application is still locked or whatever. While in an integration system, you run it against the real servers. So there's one thing that you will only discover with integration test. So let's imagine I have 4 servers. It will be hard, but I try. Server A, B, and C. 3 are enough. So I talk to A. A is changing something in B. Afterwards, I talk to C. C is asking for data from B. These things you will only cover in the. If that data is related, you will only cover it in integration tests. So here, my approach does not help. Consumer-driven contract tests don't help. This is one of the strengths of integration testing. And if you have very small microservices and let's say your boundaries are not so ideal like they should be in theory, then this is a problem, and you can only discover it with integration tests, or you discover it live when there's a bug. Then comparing them to what I explained here is, so the important thing about consumer-driven contract tests, consumers give you the testing data. So finally what it is about, 2 teams, people have to speak about their ideas how something works. So formalizing it with a common format helps, but the problem may be if it is more complex than an independent request. If it is only about an independent request, it's consumer-driven tests are nice, but I think it's as nice as talk to people and say what they want, and you build once the interface, once it works, you don't change it, everything is fine. So this whole thing about writing a document, sending it to other people, or if you really want to talk about consumer-driven tests with a packed server that stores all the things, I still think it's easier if people just talk to each other. And it will help, because once you figure out how it works, then you are done, because this is a discovery phase. And the discovery phase, you cannot really formalize unless your formalization is send documents between people until everybody agrees. The other thing about consumer-driven contract test is a promise. So one thing that you have with APIs is sometimes you really would like to remove some old endpoints with some shitty code. And it would be nice if you know that nobody's using it anymore. And one of the promises of consumer-driven contract tests is people, when they don't no longer use one of your endpoints, they update their contract tests, and so you know that nobody's using it anymore. Still waiting for the first person who tells me that this has ever worked. Because that would be really nice. So yeah, it's use it if you like it, but be aware that sharing this contract is maybe a burden, especially if you talk about a bug server. Then you will think that it provides you much more than it really does. Welcome.
Are you using this approach in microservice environment or more legacy?
Microservice environment. If it comes about legacies and more about the circuits that are created out of the fake monolith. I think it can be, theoretically, it can be done with let's say, legacy monoliths, because monoliths, it can be done with a monolith and can be really done with a monolith as well built. But I think if people are talking about monoliths, they are talking about these applications that are 10 years old, etc. I think that the problem is that the number of tests that you need to have is too big. Because you start from 0 and you have to go to thousands or whatever.
Yeah, that's if you are a microservice, you deploy. What is your rollback plan or rollback, and how do you guarantee that you don't break, right? I'm expecting there's a state, you need a state somewhere that I'm expecting that you don't change the data structure between the deployment or something that has to be found.
Yeah.
Strategy.
Yeah. So the question was about what is in that case the strategy for rollback. So let's say start with the right answer. I did it a few times and not very often. Whenever you make a change, you already write the script or the commit that you need to roll back, especially if it is about database changes. So once you change something that writes the database or reads something in the database, and you deploy it, you should already have the script that can revert the changes in case of a rollback. I rarely did this. Once I had to communicate with an invoice system, yes, it's worth to do it. So again, that's the thing about how much time, money do you invest against how much risk can you take. You had a second part of the question, I forgot it.
No, that's really good because, like, Booking.com in the past used the approach to be always compatible with the previous version, right? And if you change a database, you don't change in a way that the previous application version is not able to read.
Yeah, okay, so talking about Booking.com, the answer was you always do the changes that you can roll back. Yes, of course, as we always did. So for example, you know the typical database change. You first add a column, you write to 2 columns, then you stop the write with the existing columns. What we have more to care about is what if your error only is visible or somebody knows that there's an error after 1 or 2 days. So because this is deployment where you write to the old and to the new one, you will finally stop it somewhere. And usually we stopped it after few hours. So the other case where we cared about having already the rollback strategy, the code was more about things would only appear 2 or 3 days later because the business was not a continuous business.
It's not continuous business, or you have a training mechanism to retire the
So just explain why it was not a continuous business. Some things only happen at the morning at 3 and are done at 4, and nobody cares about it for the next 23 hours. More questions? Otherwise, was nice that you all have been here. So, Thought Labs, you will remember it.